Hi everybody, we're going to talk about velocity and acceleration again. Now we're going to use our equations. Now we're going to learn equations that you will use for the first quarter for most people of their year. These three equations are very, very important, very helpful, but you will actually use them quite a bit. Now I'm going to say that other teachers might have a ton of other equations to use. Honestly, these three equations here are the only ones you need, and then you can do the algebra to get rid of what you need. It's also interesting because some students will say, I just don't know which equation to pick. Well, now you only have three equations to pick. So you can only have three equations that you pick, and I'm going to talk about how to pick the right equation with what you're given. Okay, so here we go. First slide we're going to talk about. Before we get into it, I want to remind you about a very important list. It is extremely important to organize your thoughts, but really organize your units and the variables and everything so you have them all listed. So you might have one that's going to be position displacement, okay? So you would say, all right, well, I'm going to talk about either position or displacement, and sometimes position and displacement are really going to be the same when it comes to calculation. So I'm going to put position and displacement together on one line. We're going to have two different letters. Either it's going to be position and really final position. So X sub F for final position, or it will be displacement, the letter D. All right? Those variables, either one could be used for it, and it depends on which equation we use. Now, the units for both will be meters. So you would put M next to that in the list, and then you know that that's going to be, anytime you see meters, you know you're talking about position or displacement. And then you could even have questions, how far. So if a teacher asks how far does this travel, that's going to key you into the fact that it's talking about position or displacement, and you would be solving for that. All right, next one, time, would be the letter T. We measure time in seconds, always in seconds. Velocity, letter V, we measure in meters per second. And then finally, acceleration is meters per second squared. Okay? All right, so let's move on to the next slide here. Here are your three equations. These are how I write my three equations, the big three. The first one is going to be V final equals V initial plus acceleration times time. So the VF, V sub F, notice how it's not a V and a large F. It's a subscript F. So it's a regular letter V with a little subscript F, because that F is describing the letter V for velocity, meaning it's final velocity. So final velocity is equal to initial velocity plus acceleration times time. All right, so that's your first equation. So the A and the T are being multiplied. The next one is very similar to it, but it's VF squared. So it's again VF meaning final velocity, but this time we square the velocity. Okay, so VF squared is equal to VI squared, which will be again initial velocity squared plus 2 times acceleration times displacement. Notice how we have these squareds. Both the VF and the VI are squared. That's very important. We cannot miss those. We cannot forget those for later. All right. And then the last one I call the big ugly, all right, because it's big and it's ugly. But this big ugly is going to be an equation that really covers a whole lot, and a lot of times we can cancel things out that aren't going to be necessary. All right, and I'll explain what I mean by that in a second, but let's read it out. So it's going to be XF for final position is equal to XI, initial position, plus VI, initial velocity, times time. Okay, so that's multiplication there. Some students make a mistake, and when they write the T, they mix it up with the plus sign afterwards. So it's not VI plus something. Notice it's VI times T for time. Okay, then plus 1/2 AT squared. So you have 1/2 the acceleration and then T squared. And notice that the time is what's squared, not the whole thing. If it was parentheses, it would be squaring everything, okay? But we're only going to square the time in that equation, okay? All right. Now, let's talk about that first equation and how to use it. Let's make an example. Let's say that you're driving along in your car. You're already starting with a velocity of 15 meters per second. Okay? So you're starting with a velocity of 15 meters per second, and you're going to step on the gas and accelerate. And you're going to speed up at a rate of 3 meters per second squared. Okay? So you're going to speed up at 3 meters per second squared. After 4 seconds, what will be your new velocity? So what did I give you? I gave you initial velocity was 15, acceleration was 3, time was 4, okay, and we need to find VF. All right, so we'd plug and chug that in. So we'd have the 15 plus 3 times 4. So we'd have 15 plus 12, and we get 27 as our new final velocity answer. Okay? So that's how we use the equation. Now, again, notice and realize that you could be solving for any of the variables. Okay? I'm going to do with these, I'm just going to solve for the first variable that's on the left-hand side of the equal sign. But it could be that you solve for t. You could be solving for a. You could be solving for any of them. And you do need to practice your algebra. Okay? You can look for videos on how to do that algebra. But just understand that you will have to every now and then solve for a different variable in that equation. All right? How about the next equation? The next one is VF squared equals VI squared plus 2AD. So let's give another example. We're going to have an initial velocity of 3. Okay, so VI is 3. This time you're going to accelerate with 5 meters per second squared, but instead of giving you how long as in time, you're just given a distance. So let's say you have a set distance to accelerate, and we want to know you have an initial velocity after that distance. What's your final velocity going to be? So we have 3 as our initial velocity, we have 5 as our acceleration, and we have 120 as our displacement, the d that's going to travel. Okay, so we're going to do the VI squared plus, so we're going to have 3 squared plus 2 times 5 times 120. Okay, now after you get that answer, you'd have to square root. So I'm just going to show you on my calculator, because notice that the answer, final answer, V final is not, it's not V final by itself, but it's VF squared. So what you will do is you'll square root it. So I would have, I suggest a lot of people starting with the square root sign right in there. Okay, so I would start with the square root, and I would say, all right, my V initial is 3, and that gets squared, plus 2 times acceleration of 5 times 120. All right, and let's see if you can see that. Whoa, a little too bright. There you go. That's what mine looks like. Now notice that the 3 can't come out. Okay, a lot of people will think, oh, well, it's a square root and a square, so the 3 can just come out. And that's not true because it's being added to the rest. Okay, so don't just try taking the 3 out. But I get an answer of 34.8. So my final velocity, I started with a velocity of 3. If I accelerate at 5 meters per second squared for 120 meters, 120 if I said 20, all right, then I'm going to get a new velocity of 34.8 meters per second. All right, last one, the big ugly. So here's the big ugly. You're going to have initial velocity. You're going to have initial velocity, or I'm sorry, you're going to have an initial position. You're going to have acceleration. We can put all this stuff in it. Let's use an example of it. Let's say that you are going to return a punt. You're playing football and you're about to return a punt. So you are going to run up and catch the ball on the 4-meter line. Pretend you're playing in Canada so we can deal with meters. Okay? So I'm going to run up and catch it on the 4-meter line. As soon as I catch it, and I've already been moving with a velocity, so I'm going to be moving and running up to it, and when I catch it, I already have an initial velocity of 1 meter per second. As soon as I catch it, I am going to accelerate. I'm going to speed up with an acceleration of 6. Okay? After 2 seconds, so we'll say that we're playing for a certain football team in the local DC area. After 2 seconds, I get tackled. Where am I going to end up? What is my final position? All right, so I have initial position, I have initial velocity, I have my acceleration, and I have time. You could plug this all into the equation and figure out on what yard line or meter line I'm going to end up with. Okay, so you could plug that all in. So I could do it on my calculator here. My initial position would be 4. My initial velocity, so plus my initial velocity, which was 1, times my time, which was 2. Okay, plus 1/2, which I put in as 0.5. So multiply that times 0.5. Times my acceleration, which I have it to be 6. All right, times my time again, but this time I'm going to square it. All right, so it should look like that right there. Okay, so I hit enter, and I'm going to end up on the 18-meter line, which sounds about right for a certain local football team. Okay, so that's it for the equation. Again, I want you to understand that for any of these, you should expect to solve for a missing variable. That last equation, I want to remind you too that a lot of times you are not going to have all those numbers to put in. It's called the big ugly because it can handle a lot, but really it's not always going to be all those things. Most of the time your initial position will be 0. I would say 99.9% of the time your starting position nobody really cares about. We just care about how far you travel. So 99.9% of the time your initial position will be 0. Okay? A lot of times your starting velocity would be 0. If you're sitting at a light and then you step on the gas and go, your initial position or initial velocity was 0. Okay? When we talk about falling objects, when you drop something, that initial velocity is 0 too. So a lot of times even VI times t will be gone. Right? So all we're going to have left is the 1/2 AT squared. So there you go. There's a general idea of these 3 equations. I'll have another lecture on when you're given a problem, how to pick the right equation to use, and then going through those steps. All right, that's it. Thank you.